Good evening, everyone. Let's begin with the bridge course, Bridging the Gap, Mastering Physics Essentials, yet another session on bridge course. Today, we're going to consider resistors, series and parallel. All right. So, students, are you all ready? Good. Good. All right. All right. Let's get started, students. Students, I've got two resistors. Tell me, are they in series or parallel? The way they are connected between A and B, the nodes A and B, between A and B, two resistors are connected, R1 and R2. All right. The resistors, R1 and R2 are resistors over there, elements. Resistors have shown it with a box. All right, symbol for resistance you already know, but here I'm representing that with a box. So these are in series, right? So what is the resistance, equivalent resistance between A and B, students? Good, Shashank. Yes, that's right. Absolutely right. Now, what's the effective equivalent resistance between A and B? Good. Excellent. Gayatri, how about you? What do you think is the resistance? Yes, it's R1 plus R2. Excellent, students. So equivalent resistance between A and B of two resistors R1 and R2 connected in series is R1 plus R2. I've got resistors in parallel. All right. Now, look at this, students. Yes, Gayatri, that's absolutely right. Now, between A and B, the two resistors are connected in parallel. Now, what do you think is the resistance, equivalent resistance between A and B? Whenever you talk of resistance, yes, Shashank, that's absolutely right. Whenever you talk of resistance, you talk between 2 points, two considered points. Here, A and B. All right. Whenever you talk of equivalent resistance, you talk of equivalent resistance between 2 points. You don't talk resistance at a point. We talk equivalent resistance between 2 points in a network. Yes, Shashank is absolutely right, but that is equal to 1 by R equivalent. Yes, so one in R parallel, RP, 1 by RP is equal to 1 by R1 plus 1 by R2. So R1 R2 by R1 plus R2. Hello, Ria. Yes, absolutely right. Yes, guys, that's absolutely right. Now let's go forward. I've got two resistors, 6R and 3R. All right, or 6 ohms and 3 ohms, let's say, but 6R and 3R in general. I have to find out the equivalent resistance between A and B. Now they are in parallel, right? So can you tell me the equivalent resistance? Find out equivalent resistance and tell me whether it's 1R, 2R, 3R, 4R, 5R, 6R, 7R, or 9R. Quickly work it out and let me know. Okay, Ria says, all right, good. Excellent. Okay, that's it. Shashank, just check your calculations again. I'll wait for you, Shashank. I'll give you 30 seconds. One by R1 plus 1 by R2 is equal to 1 by R equivalent. Uh-huh. Taruni says, all right. Excellent, Shashank. That's absolutely right now. Taruni, I suggest you do it again. I'll go ahead with the solution. Equivalent resistance is RP, let's say. So 1 by RP is equal to 1 by 6R plus 1 by 3R. So which is equal to 1 plus 2 by 6R. Which is equal to 3 by 6R. So RP is equal to 6R by 3, which is RP is equal to 2R. Now note one thing, students, over here, written in on the screen with the yellow font. Equivalent resistance is always in parallel network. Equivalent resistance is always lesser than the smallest resistance in the network, in the parallel network. Lesser than the least. Equivalent resistance in parallel of a parallel network is lesser than the least. In series, equivalent resistance is greater than the greatest. Note this point. This is a very interesting point, students. Equivalent resistance in parallel is lesser than the least. మనకి 6 ఇంకా 3 6R ఇంకా 3R ఉంది కదా, మనకి ఎంత వచ్చింది 2R వచ్చింది, which is lesser than the least ఎంత ఇక్కడ 3R. If you want, you can try this with many other resistances. 2R is less than 3R. అదే సిరీస్ లో ఉంటే 6 + 3 9, which is greater than the greatest 6R. So that's an interesting and point in which can be used in solving numericals faster. Equivalent resistance in parallel of a parallel network is lesser than the least resistance in the parallel network. Equivalent resistance of a series network is greater than the greatest element in the series network. All right, is it clear? నేనేం చెప్పింది clear, students? Is it clear, students? Whatever I spoke about, lesser than the least and greater than the greatest. All right, good, excellent. You people are faster than I think. Good, students, good. All right, now look at this. Identify the wrong answers without calculating the RP. We just noted a statement, right? That equivalent resistance is lesser than the least in a parallel network. So I've got 10R and 4R. I have to identify the wrong answers without calculating the RP. RP is between 2R and 3R. It could be 2.5 or something like that. RP is between 3R and 4R. That's supposed to be capital R. That's okay. RP is between 3R and 4R. Is that possible? RP is between 4R and 6R. RP is between 6R and 8R. RP is between 8R and 10R. RP is between 10R and 14R. RP is more than 14R. Which one do you think is wrong? I revealed one wrong answer. I revealed one wrong answer. Now you have to spot all the wrong answers in all the options. 7 options you have got. ఈ 7 options లో wrong ఏవేవి మీరు చెప్పాలి. ఇంకా ఎందుకు? Why is it wrong? Yeah, 7th one, someone says is wrong. Who is it? Shashank says 7th is wrong. Okay. Tarani also says 7th is wrong. She agrees with Shashank. Why is it wrong, students? Riya says 6 and 7 are wrong. Gayatri says 6th is wrong. Okay. Can you mention why is it wrong, students? Shashank says 5, 6, 7 are wrong. Riya says 6 and 7 are wrong. I'll go to the statement again. Equivalent resistance of a parallel network. Yes, Gayatri. Yeah, you're almost right. I'll reframe this. I'll repeat the statement. The equivalent resistance in a parallel network should be lesser than the least element of the network. దీంట్లో least element ఏంటి? 4R or 10R or 4R. So my equivalent resistance should be lesser than 4R. Shashank, you're almost there. Excellent. Good. Taruni. Very good. Okay. I'm waiting for others to answer. Gayatri and Riya, I'm waiting for your answers. Equivalent resistance should be lesser than the least. Excellent. Riya and Gayatri, everyone is on the same page. Excellent. One, I've already shown 3, but rest which are wrong are 4, 5, 6, and 7. Let's see. Everyone is on the same page. Excellent, students. This is wrong. This is wrong. This is wrong. This is wrong. Why? Why is it wrong? Because my resistance should be lesser than 4R. But here it says 4R and 6R, 6R and 8R, 8R and 10R, 10R and 14R, 14R, above 14R, which is not possible. So it has to be less than 4R. So 1 and 2 are possible. But how do I find out whether it's 1 or 2? I have to calculate. I can eliminate the possibility of what are wrong by the logic. But if I have to calculate what exactly resistance is, yes, Gayatri, that's absolutely right. RP should be lesser than the least. Absolutely right. So, but if I have to find out whether it's 1 or 2 is correct, which of this is correct, then I have to find out, calculate and find out. But question said, without calculating RP, you are supposed to spot wrong answers, and you have done it. Thumbs up for that. Good. Excellent. I love teaching you all. All right, here's a statement. RP is always lesser than the smallest resistance. Now let's take the correct answer. Equivalent resistance is RP. So one by RP is equal to 1 by 10R plus 1 by 4R. Simplifying further, RP is equal to 20 by 7R. 1 by RP is equal to 7 by 20R. RP is equal to 20R by 7. So that's approximately 2 point something. So that's between 2R and 3R. No, option 2 is not wrong, Shashank. Option 2, see, option 2 says RP is between 3R and 4R. 3R ఇంకా 4R మధ్యలో ఉంది కదా. It's between 3R and 4R. So that's right. It could be right. Whether it's right or not, I have to calculate and see. But that could be right. That's definitely not wrong. But above 4R is definitely wrong. You got the point, Shashank. We are going by contradiction. We are logically deducing what is wrong. Because we know the statement, logical statement. Based on that, we are saying that this is definitely wrong. And what is right, I have to calculate and do it. Okay, Gayatri, is it between 3 and 4? No, no. It is 20R by 7. So that's 2 point, how much? 8 something. Yeah, 2.828, so on. So it's between 2R and 3R. Gayatri, convinced? All right, good. Now I can say that 2 is also wrong. How could I conclude 2 is wrong? By calculating. But how did I conclude 3 to 7 are wrong? By logic. All right, now let's go for the next one. Okay. Now, by logic, we can eliminate the wrong options. Now, this is how we can usually eliminate wrong options in competitive exam students. ఇలాంటి చాలా tricks ఉంటాయి, techniques ఉంటాయి that we learn when we do IIT JEE coaching. But ఇలాంటి చాలా ఉంటాయి. So let's read the statement. As RP is always lesser than the smallest resistance 4R, there are two options out of which one is correct. After calculation, we have to check which is correct. 7 options were given, out of which only these two may be correct. But out of only these two, one is correct. But 3 to 7, they're definitely wrong. This process is called eliminating the wrong options. All right. Now look at the another example. I've got 3 resistors connected like this. I have to find out the equivalent resistance between A and B. As I told you, equivalent resistance is always, if I just ask you to find equivalent resistance, you should say, sir, question ముందు కంప్లీట్ చేయండి అప్పుడు కనుక్కుంటాను. ముందు క్వశ్చన్ కంప్లీట్ ఉండాలి. క్వశ్చన్ ఏంటి? Find the equivalent resistance between 2 points. Between 2 points A and B. Those 2 points have to be mentioned. Without the 2 points being mentioned, the question is incomplete. You should say, sir, question complete లేదు, నేను చేయలేను. Question complete చేయండి, నేను కనుక్కుంటాను. All right. So that's a very important, simple point, but it makes sense. Okay, let's find out what is the equivalent resistance between A and B. Can you quickly find out, students? స్టూడెంట్స్ ఇంటర్మీడియట్ లెవెల్లో మీకు ఏ నెట్వర్క్ ఇచ్చినా ఒక స్ట్రాటజీ ఉంటుంది టు ఫైండ్ అవుట్ ద ఈక్వివలెంట్ రెసిస్టెన్స్. ద ఫస్ట్ లైన్ ఆఫ్ థాట్ ఈజ్ సిరీస్ అండ్ ప్యారలల్. అందుకే మనం సిరీస్ ప్యారలల్ ముందు చేస్తున్నాం. Then comes Wheatstone bridge, then comes nodal network. So there is a strategy of how to attack a problem in current electricity. ఒక ఎలక్ట్రిసిటీ ప్రాబ్లమ్ ని అటాక్ చేయడానికి ఒక స్ట్రాటజీ ఉంటుంది. ద ఫస్ట్ లైన్ ఆఫ్ థాట్, ఫస్ట్ లైన్ ఆఫ్ అటాక్ ఇస్ సిరీస్ అండ్ ప్యారలల్. సో వీఆర్ బీయింగ్ కంఫర్టబుల్ విత్ సిరీస్ అండ్ ప్యారలల్ ఫస్ట్. I'll also give you a food for thought as a homework. మీరు ఆలోచించి మరి నెక్స్ట్ క్లాస్ లో చేద్దాము. బట్ రైట్ నౌ లెట్స్ డూ సమ్ ఎగ్జాంపుల్స్ ఆన్ సిరీస్ అండ్ ప్యారలల్. All right. Did you calculate the equivalent resistance of this network between A and B? Try చేయండి. That's okay if you go wrong. Just a session. We are just practicing something. We are learning. You're all trying. All right. I'll give you 30 more seconds. No, just come up with an idea. We'll solve it together. Don't worry. Just come up with an idea. Aim చేద్దాము. What do I do? I've got three resistors. It's between 3 and 4. ఓకే. నో స్టూడెంట్స్, ఇప్పుడు ఆ థాట్ అయిపోయింది. లెసర్ దెన్ ద లీస్ట్ ఐడియా అయిపోయింది. నో వీఆర్ ఎంటరింగ్ టు సమ్ సిరీస్ అండ్ ప్యారలల్ నెట్వర్క్. సో దట్ థాట్ ఇస్ ఓవర్. విల్ కమ్ అక్రాస్ ద థాట్ అగైన్ అండ్ అగైన్ ఇన్ ప్యారలల్ నెట్వర్క్. ప్యారలల్ నెట్వర్క్ వస్తే ఆ థాట్ వస్తుంది. ఆ లాజిక్ ఖచ్చితంగా విల్ కమ్ అక్రాస్ దట్ లాజిక్ అగైన్ అండ్ అగైన్. బట్ వాట్ ఐ మీన్ టు సే ఇస్, ఇది ఎలా అటాక్ చేస్తాం, ఎలా చేద్దాం, ఇది ఈ ప్రాబ్లమ్ ని క్రాక్ ఎలా చేద్దాం, ఈక్వలెంట్ రెసిస్టెన్స్ కనుక్కోవాలి. ఫస్ట్ ఏం చేద్దాం? Let's see. I'll initiate the thought process, students. This can be simplified like this. How this R and R between A and C, between A and C, there are two R's and they are in series. They are in series, right? R and R in series. Do you agree with that? You all agree with me that R and R are in series? R in series. Triple R. Triple R movie. No. We are talking about resistors. Okay, they are in series. Agree, right? Yeah, good. Now, when they are in series, their equivalent resistance is R plus R, which is 2R. Agree with that? Okay, yes, all right. Now look at this network, students. I can further analyze this as this R and 2R are in parallel. On the left-hand side, between A and C, I had R and R. Those R and R were in series. Now that R and R became 2R between A and C. So between A and B, I have R. Between A and C, I've got 2R. Yes, Gayatri, that's parallel. Now R and 2R are in parallel. Excellent. Before R and R were in series, R and R were in series. It's like a tongue twister to me. R and R were in series, but now this R and 2R are in parallel. Agree with that? You all agree with me? Okay, agreed. All right. Now tell me, what do you think the equivalent resistance would be? Will it be more than 2R, between 2R and 2R, or less than R? Absolutely right, Shashank. That's absolutely right. I really appreciate that. But before that itself, we can conclude that that has to be less than R. Why? Because equivalent resistance of a parallel network has to be lesser than the least. Least over here is R, so that has to be lesser than R. Now let's find out. 1 by R plus 1 by 2R, so on. So further simplifying, 2R by 3. So RP is 2R by 3. What is 2 by 3 less than 1? So it is lesser than R, around 0.66 R, which is lesser than R. That makes complete sense. Yes, less than R. Excellent students. Ria, Gayatri, Shashank. Taruni, I'm waiting for your answer. Please participate. All right? Don't hesitate. Participate. All right. Now let's go further. Let's look at this resistor network, students. Now I've got a network of resistors like this R, 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 and R. I have to find out equivalent resistance between A and B. How do I do this? The first line of thought whenever you see a network is to spot series and parallel. ఏది సిరీస్ లో ఉన్నాయి ఏది ప్యారల్ లో ఉన్నాయి స్పాట్ చేయాలి ముందు. సింప్లెస్ట్ విల్ బి సిరీస్. ప్యారలల్ స్పాట్ చేయడం కొంచెం కష్టం, కానీ సిరీస్ స్పాట్ చేయడం ఈజీ. So these two are, this corner are, Gayatri. Yeah, I think you're partially correct, Gayatri. I mean, your first line of thought is correct, but I think you're going wrong somewhere. I'll tell you where. Uh-huh. Okay, good attempt, Shashank. Good attempt. Mhm. No, in this case, Ria, it will not be less than R. Only in the case of parallel, it is lesser than the least. We also have to spot whether things are in series or not. It's an interesting situation, students. Let me grab a pen. Just a second. Give me a second, students. Till then, you think. I'll initiate the thought process. See, R and R are in series. These two R's are in series. The cornermost R and the upper right, uh, top right corner R are in series, right? So that becomes 2R this way. Now this 2R and R are in parallel series. Think R and 2R are in parallel or series. This R and 2R. You think I'll grab the pen and be back. Students, please think about it. I'll give you 2 minutes of time. Students, any idea? Okay, Shashank has got an answer. All right. But Shashank, why have you written 1 by 2r plus 1 by 2r? Like, do you see 2r and 2r are in parallel? Let me quickly grab a pen. Just give me a second. Okay, R and R in series. There is a mistake, Shashank. This is what I wanted to teach you. R and R are not in series. You can call them in series, but you have a junction in between here, right? So that's not in series. R and R are not in series. R and 2R are in parallel this way. So I get R parallel as 2R by 3 of these two resistors, R and 2R, which I further reduce it to 2R by 3 this way. Then this 2R by 3 and R are in series. Now they are in series. Now this combination is in series with R. First, R and 2R you had, we are in parallel, which were in parallel. Now that parallel combination is in series with this R. So R and R were not in series. Note that R was isolated, separate. This R and 2R were in parallel. This parallel combination was in series with is in series with R. Is it clear, Shushank? Is it clear to everyone? Well, that was a good attempt. I appreciate that. Shushank, that was a good attempt. Okay. Now, what I get is 2R by 3 plus R is how much? 5R by 3. So my equivalent resistance between A and B is 5R by 3. Look at that. 5R by 3 is definitely greater than R. How could it be greater than R? Let's come back to situation again. I got R and R in series. That became 2R. Fine, that's perfectly fine. Now R and 2R are in parallel. That becomes less than R. Less than R, which is 2R by 3. 2R by 3 is 0.66 R, which is less than R. Now this 2R by 3 and R are in series. Whenever you have two resistances in series, you will have equivalent resistance greater than the greatest. What is the greatest here? R. So your equivalent resistance should be greater than R, which is 5R by 3, which is around 1 point something, 1.66. Convinced? So whenever you see a series parallel network, that thought should come to your mind. Is it lesser than the least, greater than the greatest? You should keep that thought in mind whenever you are solving a series parallel problem. All right, that will keep your mind focused on the answer. Sometimes you can skip the steps as well. Sometimes you can eliminate the answers as well. Is it clear, students? Okay, yes, Gayatri, that's absolutely right. స్టూడెంట్స్ మీకు అర్థమవుతుంది కదా నేను మళ్ళీ చెప్పమంటారా మళ్ళీ ఒకసారి చెప్పమంటారా ఓకే రియా సేస్ ఇట్స్ క్లియర్ శశాంక్ మళ్ళీ చెప్పమంటారా మీరు తరుణి ఆల్ రైట్ నో ఆల్ రైట్ ఆ థాట్ ని ఆ లాజికల్ స్టేట్మెంట్ ని మీరు గుర్తుపెట్టుకోవాలి ఆల్ రైట్ గుడ్ దట్ in series greater than the greatest, in parallel lesser than the least. So that thought should come to you whenever you attack a series parallel problem. మీరు స్టెప్స్ స్కిప్ చేయడానికి ఛాన్సెస్ ఉంటాయి ఆప్షన్స్ ఎలిమినేట్ చేయడానికి ఛాన్సెస్ ఉంటాయి ఇప్పుడు చూసాం కదా ఇంతకు ముందు ప్రాబ్లం అలా ఆప్షన్స్ ఎలిమినేట్ చేయడానికి మనకి లాజికల్ థాట్ ఉంటుంది రైట్ నౌ లెట్స్ గో ఫార్వర్డ్ నౌ లుక్ ఎట్ దిస్ స్టేట్మెంట్ దిస్ network students. I've written 1 1. So let's say it's 1 ohm, 1 ohm, and this is X ohms. I wanted to find out finally what is the equivalent resistance between A and B. Students, just give me a second, I'll just grab the pen. Okay, we have got answers here. Good. First parallel connection, Gayatri says, and then series connection should be calculated. Excellent. Excellent. Now let's wait for the others to answer. Shashank has given me the answer directly. Okay. Shashank, Riya, are you confident that your answer is right? Okay, Riya, yes, yes. I am confident that you'll crack competitive exams very easily. Excellent, Riya and Shashank. Gayatri, excellent. How about Taruni? Where is Taruni? Yes, Gayatri, that's right. So for parallel connection, I'll have R1 R2 by R1 plus R2. All right. Just a simplification. 1 by R equivalent. I'll just write it down here. 1 by, oh, sorry. Just a second. 1 by R equivalent is equal to 1 by R1 plus plus 1 by R2. 1 by R1. Oh, I'm sorry. 1 by R1 plus 1 by R2 is equal to 1 by Rx equivalent. So how can I write this? I'll write Rx is equal to R1 R2 by R1 plus R2. So whenever you have two resistances, you can quickly think of R1 R2 by R1 plus R2. So I've got X and 1. I'll write it as X into 1 by X plus 1. I got the equivalent resistance of these two resistors. Now this is in series with 1 plus 1. Now this is my R equivalent. So that would be X plus 1 by X plus 1, which is, as you all said, 2X plus 1 by X plus 1. Absolutely right, students. Now we are going towards a very good question, students. For today, I'll just leave the question with you. Question అడిగేసి నేను చెప్తాను మరి మీరు ఆలోచించండి. So you'll have a quadratic equation involved in this solution. So let's go for the next question, next slide. ఇక్కడ చూడండి students. I have got a network, 1 ohm, each resistance is 1 ohm, okay? Not mentioned, but it's each resistance is 1 ohm. 1, so on till infinity. This is a very important practical engineering model, students. Not just engineering, but in biophysics also, in neuroscience also. This models how the neurons in the brain function. All right, this infinite ladder network, this is called a ladder network. Ladder అంటారంటే ladder ఎందుకు అంటారంటే చూడండి ladder లాగా ఉంది కదా ఇది. స్టెప్స్ ఉన్నాయి. ఎక్కుతాం కదా ladder పెట్టుకొని ఎక్కుతాం కదా. ladder లాగానే ఉంది కదా నెట్వర్క్ చూడడానికి ladder లాగానే ఉంది కదా. Do you all agree? ఒక ladder లాగా కనిపిస్తుంది కదా. నిచ్చెన, yes నిచ్చెన, it's like నిచ్చెన. You all understand నిచ్చెన and ladder, right? It looks like ladder itself. నిచ్చెన లాగా కనిపిస్తుంది కదా ఇది. Students, yes or no? Yes, yeah, good. Yes. So that's why it's called a ladder network. All right. This has got significance in neuroscience, in electronics engineering, and also in quadratic equations. We'll see how. But to our extent, to this level, we can understand this from the perspective of current electricity and quadratic equations. This ladder network also models how neurons in the brain function. All right, that you will understand later. But as of now, the question is, students, you can think about it. But one sincere request is, do not search for the answer in Google. Try by yourself. It's a very good question. I'll complete the question. First, listen to the question. I'll initiate the thought process. But I'll tell you one thing. Students, మీరు Google లో search చేస్తే ఏం రాదు. మీరు try చేస్తేనే వస్తుంది. I'll add to it. I'll add some interesting points to it which you will not find in Google. All right. I'll add some interesting points to it which you will not find in Google. All right, so try it by yourself. And let me complete the question, students. ఈ నిచ్చెన ఉంది కదా. So I have to find out equivalent resistance between A and B. Is a question. Till now we have done ఈ పార్ట్ వరకు చూసాం. ఈ పార్ట్ వరకు చూసాం. ఈ పార్ట్ చూసాం కదా ఇప్పటి వరకు 1 ఉండే వరకు. But now what I do, I have to add infinite number of networks like this, infinite number of steps like this. So how do you do is the question. But you will have a finite resistance. All right. Now this is neither series nor parallel. Again, it is first parallel, then series with something. For example, I think I'm confusing you. Just a second, students. ఇది ఉంది కదా. This was these two were in series, then in parallel with this, then in series with this. Right? Similarly, so it was both series and parallel. But here, students, one mistake which you were committing is these two resistances are not in series. This one and this one are not in series, not in series. This one and this one are not in series. These two are not in series because there is a junction here. How do you identify series? First, whenever you see a network, first spot series. Series ఎలా identify చేస్తారంటే, if some current flows like this, same current should flow so the next resistor and come out of the next resistor. Then you say these two resistors are in series. When do you say parallel? We'll talk about it later. Okay, parallel is more interesting. But how do you say series? Whenever some current flows, enters into R1, should exit from R1 and should enter the next resistor. But ikkada em chudandi em avutundi. Let me just clear this. 1 second, students. Gayatri, that's not that easy. You'll have to frame an equation and solve the quadratic equation. You'll have a beautiful answer, which is not as simple as 10r by 3. But I appreciate your attempt, students. But that's not as simple as 10r by 3. It has got a very, one of the finest models in JEE mains and advanced students. ఇలాంటి questions చాలా వస్తాయి. Now look at this, students. Some current is flowing here, entering this one. Same current is exiting here, but this current is being split here. So this same current is not, let's say, I1, ఇది I2, ఇది I3. This I1 is being split here and here. So same current I1 is not entering this R. When this same current I1, but over I3 ఏమవుతుంది? I3 ఇక్కడ ఎంటర్ అవుతుంది, ఇక్కడ ఎగ్జిట్ అవుతుంది, ఇక్కడ I3 ఎంటర్ అవుతుంది, ఇక్కడ ఎగ్జిట్ అవుతుంది. Now that's why these two are in series. But whereas this one, 1, 2, 3, 4. 1 and 2 are not in series because same current is not flowing through them and there's a junction in between. Split అయిపోతుంది current అక్కడ. The current entering should be same channel. ఒక పైప్ లో వాటర్ ఫ్లో అవుతుంది కదా, ఆ వాటర్ స్ప్లిట్ కాకుండా ఒక రెసిస్టర్ నుంచి ఇంకో రెసిస్టర్ కి ఫ్లో కావాలి. సో ఒకటే ఛానల్ లో ఫ్లో కావాలి. ఇక్కడ ఒకటే ఛానల్ ఎలా ఉంది, ఆర్ నుంచి ఇలా ఫ్లో అవుతుంది, ఆ ఛానల్ లోనే ఈ ఆర్ వరకు వస్తుంది, ఫ్లో అవుతుంది. బట్ ఇక్కడ స్ప్లిట్ అయిపోతుంది కరెంట్. సో దట్స్ నాట్ ఇన్ సిరీస్. దట్స్ ద మిస్టేక్ యూ ఆల్ కమిటెడ్. దట్స్ ఓకే, అబ్సల్యూట్లీ ఓకే. బట్ నౌ లెట్స్ కమింగ్ బ్యాక్ టు ది క్వశ్చన్. Okay. Now look at the students. ఇక్కడ ఇన్ఫినిట్ నెట్వర్క్ ఉంది. సో దేర్ ఇస్ నాకు లాస్ట్ ఎలిమెంట్ దొరకదు. నేను లాస్ట్ అనుకుంటే స్టూడెంట్స్ ప్లీజ్ నోట్ డౌన్ ద డయాగ్రామ్ నోట్ డౌన్ ద ladder diagram, ladder network, నిచ్చెన నెట్వర్క్. Please note down the diagram. It's one of the finest problems in IIT JEE mains and advanced students. ఇలాంటి చాలా వస్తాయి, but we are doing with resistors. This also models the functioning of neurons in brain. And each box over there is 1 ohm. Are you all noting down, students? Note down in your notebook. Be careful with the diagram. చూడండి, ప్రతి నోడ్ మధ్యలో ఒకటి రెసిస్టర్ ఉంది. All right. And each box is 1 ohm. Infinite ladder ఉన్నా కూడా మనకి finite resistance వస్తుంది. We are just finding out the equivalent resistance. We are not solving the network. So we will solve the network eventually when you join intermediate classes, coaching law. But right now we are just finding the equivalent resistance. So we need to frame an equation. We get a quadratic equation. We'll have two solutions for that. One is negative, one is positive. We'll pick up the positive because negative resistance doesn't make sense in this case. Are you all noting down, students? Have you noted down? Please make it quick. Noted. All right. Shashank has noted. I appreciate that. Gayatri, Riya, Taruni. Right. Good, Gayatri. Thank you. Riya, have you noted? Is Riya here? Oh, other students have also joined. Manisha, hi. Ashwini, Chintu. All right. Noted. Please note this diagram. Each box is 1 ohm resistance. Any doubt in the question, students? You have to find out the equivalent resistance between the points A and B. And the ladder is infinite. Infinite, never ending. All right. Even if you go for 1 crore, 10,000 crore, millions and millions and millions and million crore elements. Sorry, millions and millions and millions and millions elements, you'll still have an element. All right. So don't think you can do series parallel, and come back to the first element. Even if I stretch this ladder from Hyderabad to Nizamabad, it will not end. It will even continue further. All right. Even if I draw this network from Hyderabad to Nizamabad, it will not end. It will continue further towards further districts. All right. It is infinite network. So the logic behind to crack it, it's different. The thought process, ఆలోచించండి. It's good. It's a food for thought. ఎంత ఆలోచిస్తే అంత మంచిది. Physics is the brain gym. Brain కి ఎంత exercise ఇస్తే అంత మంచిది. All right. I'll leave you with this question. Any doubts in the question, students? I would like to end the session. Any doubts in the question? All right. All right. Good. All right, students. So see you tomorrow with yet another session, yet another topic. But do try this question. So as of now, all right. Okay. No, sir. No, sir. All right, students. Are you all aware of Super 20 batch which you have introduced? We are introducing a Super 20 batch coaching, who will be given coaching worth 1,20,000 for free. scholarship of 1,20,000, but the coaching is going to be for free, completely for free for 2 years for JEE mains and advanced and NEET. And we are going to conduct an exam on 2nd of June. The ones who are toppers in the exam, or you have registered for the exam, Gayatri, good. The toppers in the exam, selected students, top 20 students will be given free coaching for 2 years with a dedicated mentorship program. All right. You'll have daily practice sheets, exams, doubt sessions, paper discussions, mentorship sessions, counseling, and everything that is required for you to crack JEE mains and advanced and NEET. All right. If you haven't registered, do register. You'll experience where you stand in the exam. Exam syllabus is 10th class syllabus and aptitude, general aptitude. Inform all your friends, students. Where friends could inform cheyandi, register cheyamani. It's a good opportunity, I suggest. To get selected in the top 20 is no joke. Syllabus is 10th class syllabus and general aptitude. You'll have both the sections, math, physics, chemistry, and general aptitude. And for BC, you'll have bio, physics, chemistry, and general aptitude. Is it clear, students? All right, good. All right, students, that's all. I leave you with this food for thought. Think about it. Physics is brain gym. Keep your brain active. Keep your brain